Hello everyone. This is our course project on face identification presented as a part of the course Pattern Recognition and Machine Learning. Our team includes Sandeep, Atanu, Japneet, Varchasva and Vishal. The goal of our project was to build a robust face identification system capable of classifying a face image into one of the k-known identities. A major real-world use case we focused on was automated attendance that allows people to be marked present in real time just by showing their face to a camera. Moving on to the datasets, we began with the LFW dataset, but it has major issues. Fewer samples per identity and class imbalance that makes it unsuitable for identification tasks. Then we switched to VGG Phase 2 dataset, a much richer dataset. From it, we selected 50 identities with about 325 images per person. This gives a better class imbalance and greater diversity for training our model. Then, all of these images were passed through a pre-processing pipeline. We've used OpenCV's Haar Cascades to detect and crop face regions. These cropped images were resized into 128 x 128 pixels to ensure uniformity before feature extraction. To convert these images into useful features, we have applied three techniques. LBP, which captures the local textures. Second one is HOG, histogram of oriented gradients focused on the structure and edge orientation. Finally, we use pre-trained ResNet 18 embeddings to extract deep semantic features. Each of these methods capture a different aspect of facial information from the surface level patterns to abstract representation. We combine LVP, HOG and CNN features into a single fused vector to get a richer representation of each face. Why? Because LVP capture textures, HOG adds shape details, CNN provides the deep semantics, and fusion creates a rich representation of each face. However, these vectors were high dimensional, so we applied dimensionality reduction. PCA was used to preserve variance and remove redundancy. LD helped improve class separation and made classification more efficient. All are the classification techniques we have used. How we classified the faces. Once we had our feature vector from LBP, HOG, CNN and O combined, we experimented with various machine learning models and deep learning classifiers to predict the correct identity. Let's discuss some of the traditional ML models. SVM was one of the classification technique which was the best performant on extracted features. It can handle high dimensionality data as well, and we've used RBF kernel for that, which gives an accuracy of 76%. More classification techniques include KNN and logistic regression, which gives an accuracy of 58% and 66% respectively. Another model like random forest and XGBoots was simpler but underperformed, giving around an 57 to 63% accuracy. These are ensemble based, but they struggled with high dimensional fused features. We've also used artificial neural networks with two hidden layers and ReLU activation function, which gives an accuracy of 63%. We have plotted the accuracy with different features using SVM, and we got an average accuracy of 55.82% on all. Then we plotted all the model accuracies to compare them. SVM clearly outperformed others in our actual implementation with an accuracy of 76%. We also explored a deep CNN like ResNet 50 performance, which gives a 92% accuracy theoretically. So SVM became our chosen model. It offered a good balance between performance and implementation simplicity. ResNet 50 was the top performer, but it was way more complex. So SVM, while slightly less accurate, was more practical and interpretable for this phase of project. Finally, we implemented the full attendance system using SVM with real-time face capture detection and classification on Google Cloud. Thank you.